Section 3.2 in our book here describes properties of parallel lines. And before we were talking about special angle pairs when two lines are cut by transversal. Now we're going to talk about what happens when we have a transversal cutting across two parallel lines. Now we use arrows to show that two lines are parallel, so these two lines can be shown to be parallel here. Postulate 10 says if two parallel lines are cut by transversal, then the corresponding angles are congruent. So our conclusion here is that angle 1 and angle 2 are congruent. Or we could say this angle is congruent to this angle. Or this angle is congruent to this angle. Or this angle is congruent to this angle. That's only if these lines are parallel. Theorem 3.2 says if two parallel lines are cut by a transversal, here we have two parallel lines, which we indicate with these arrows, cut by transversal, then alternate interior angles were congruent. Remember, interiors are in here, and alternate interiors are on opposite sides of the transversal. So here, angle 1 and angle 2 are congruent. We could also conclude that this angle here is congruent to this angle over here because they're alternate interior angles. Theorem 3.3 says if two parallel lines, so we're going to have to get parallel lines here again, and we'll say, we'll put an arrow here and right here. That means these two are parallel. Are cut by transversal, then same side interior angles are supplementary. So if this angle here is 70, then we know this angle here has to be 110 because these parallel lines are cutting transversal, so this has to add up to 180 with this angle here. They're supplementary. Theorem 3.4 says if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one also. So if we have two parallel lines here, like so, and we're told that we have a 90-degree angle here, then we know that these two are perpendicular as well. What this does is it saves you some time in a proof later rather than having to go through saying that this angle's equal to 90 and then saying that corresponding angles are congruent and then saying, well, then this is equal to 90 through transitive property and then saying you have perpendicular lines. You can go right from we have perpendicular here to we have a perpendicular here. And that is all the theorems for section 3.2. But it's not the end, because sometimes we have problems that are a little trickier. Here we have example 1, and this one asks us to find the measure of angle 4, the measure of angle 3, and the measure of angle 2. I'm just going to slide these over here. So to find the measure of angle 4, we're going to look right here and say, what is this angle right here? Well, looking at these two lines that are marked parallel, we have two lines here cut by a transversal here. And here's angle 4, and here's that 45-degree angle. Let's see if I grabbed it right. Now do you see, now that we're looking at it just by themselves, it's quite obvious that angle 4 and that 45-degree angle are all opposite interiors, meaning they're congruent, so angle 4 is 45 degrees. Take a look again. Do you see the alternate interiors here? Next, we're asked to find angle 3. Well, angle 3, if we look right here, we have two lines intersecting right here. Oh, that's kind of ugly. Angle 3 is vertical with 82, so angle 3 is just 82 degrees, because vertical angles are congruent. So we found angle 4, and we found angle 3. Now we're asked to find angle 2. Well, a couple choices. We could say angle 2 and angle 5 are corresponding, because we have two lines cut by a transversal, and those two are corresponding angles. If I pull it off, you can kind of see that they lie in the same spot. However, I'm not going to use that for this one. I'm going to do something a little more fun. I'm going to say I have these two lines cut by that transversal. And I'm going to say this big angle is supplementary to this angle. So I can pull that off. see what kind of special angle pair we have there. These two angles are same side interiors, so this big angle and angle 2 are supplementary, meaning that 45 plus 82, which is 127, plus angle 2 should equal 180. 180. I'll call it x for this equation. So x equals 53 degrees. Okay. This next example shows a situation where we might have to do a little bit more work to find the value of a variable. Here, we're going to be given that these two are parallel lines, and we're going to be asked to find the measure of this angle right here, x. Now I'm just going to move x out of the way here, and we'll be able to get back to that later. I have 73 degrees here and 52 degrees here, and you notice it's not one transversal going through. So I'm going to add an auxiliary line going right through here. All right, I know it looks pretty pathetic, but you get the idea. And say, all right, these two are alternate interior angles, so that's 73 degrees. And these two are alternate interior angles, so this is 52 degrees. X, remember, was this whole thing. So what do we need to do with the 73 and the 52? We're going to add them together, and we have our value of x.